Sometimes we are given equations, we are given graphs and lines that, well, are not really straight lines, they're not linear equations, and most of the equations we deal with will not be. And so we kind of want to find out what's happening to this graph, describe, how fast it's increasing or decreasing. And the best way we learned how before is to use slope, except that you can't find slope of a non-linear equation, at least not an actual slope of it. You can find an average rate of change, an average slope. Instead of saying, the slope of the line, we say, or just the linear equation, we're talking about the slope of a secant line. That is a line that goes through the graph twice, um, as, covering as much of the section of the graph as it's in question, from some initial x value to some final x value. We can calculate the slope of that line, which is, again, it's not going to be exact, but it's going to give us an average change between those 2 points. So it gives us an idea of the incline and what's happening there. And just like we did with slope before, the slope of a secant line is the second function value, or the second y. So it's like it's y2 minus the first function value. So it's like it's y1. And we divide that by x2 minus x1. Same slope equation, is just that now it's not a linear equation. So again, it is simply average rate of change, or the slope of a secant line, a non-linear equation, is the same exact thing. It's the change in y divided by the change in x. It's just that it no longer has to be a linear equation. So at this time, I'm going to ask you to calculate the slope of those two lines. They are of this graph here. You see x cubed minus 3x. I want you to calculate the slope, or the average rate of change, between -2 and -1, and between 0 and 1. These have been plotted for you. Here's the original graph. There's those two secant lines going through the graph to give us an idea of the incline. However, we know that is not the true slope of the graph because it's not linear. However, we can get an average rate. So if you want to go ahead and try that out, pause the video. If not, let's take a look. So the average rate of change, or the secant slope, between -2 and -1, well, we got to look at y2. The y value at this point here is 2, minus the y value at this point is -2. And we divide that by the x values, the change in x, which is -1, minus the other x value, -2. So 2 minus -2 is the same thing as 2 plus 2, which is 4. And -1 minus -2 is -1 plus 2. And so the average rate of change between -2 and -1 is 4. Makes sense. It's a positive slope. It is increasing. And if we can count 1, 2, 3, 4 over 1, that looks pretty good. The second one is decreasing. So what kind of slope do you expect to see for the second one if it's decreasing? Negative slope. So we go and find a y value, which is -2, minus the y value of the other point, which is 0. We divide that by the change in x, which is from 1 minus where it started off, which was 0. Now, if you reverse those values, it's not a big deal as long as you reverse both. You can't say -2 minus 0 and then go 0 minus 1. That's going to give you an opposite sign. And you're also going to notice that this thing should be decreasing, so I should have a negative slope when I'm done. And if the sign doesn't match increasing and decreasing for your graph, then you know something is off. -2 minus 0 is -2. 1 minus 0 is 1. -2 divided by 1 is -2. And as expected, we did get a negative slope because the graph is decreasing in that section. All right. One application of average rate of change is something that we call average speed. Again, if you look down at the speedometer when you drive and you're like, okay, how fast am I going? Right now. You can find out how fast you're going right then. But as we know, we don't always keep a constant speed. So you want to know if the speed is given as a function of time in seconds. S of t is equal to 20 t to the 3/2 power. And you want to find out, okay, what's my average speed between 0 and 4 seconds? Well, we need to first find out what S of 0 is equal to. We need to find out what S of 4 is equal to. And S of 0 is 20 and then 0 to the 3/2 power, which, well, 0 to any power is 0 times 20 is still 0. Then 4, it's going to be 20 and then 4 to the 3/2 power. Now, if you want to do 3/2 as an exponent, the bottom number represents the root that you're going to take, and the top number is the power. So it might actually be better, if possible, to take the bottom number out of this equation first. So what is the square root of 4? That's 2, and then 2 to the 3rd power, it's 8. 20 times 8, 160. So when you started, you're going 0, makes sense. 4 seconds later, you're going 160, and it's in terms of seconds. This could be, feet per second. That's still pretty fast, but yeah, 160 is probably not miles. It's definitely not miles per second, at least. We look at 160 as 4, so we're going to say, okay, let's find our average rate of change, the slope of our secant line. That is going to be the change in y, which is my function values. 160 minus 0 divided by the x changes, which is 4, minus 0. All right, so what is my average speed? I wasn't going anywhere at first. I was going 160. Does that mean I was going 160 the entire time? No. In fact, I was going 160 divided by 4. My average speed was 40. Now again, that could be feet per second, likely not going to be miles because it's in fact the time is seconds. The next one, from 4 to 9 seconds, if you continue to follow this equation, what does that look like? Well, from 4 to 9 seconds, I already have the speed at 4 seconds. I need to calculate the speed at 9 seconds now. So I need to calculate S of 9. That is going to be 20 and then 9 to the 3/2 power. And if you remember what we just said a second ago about 9 to the 3/2, we take the bottom number, which is a 2. That means square root of 9. Well, that's easy. That's 3. And then 3 to the power 3. That's 27. Oh, I can do that. 27 times 2 is 54. With a 0, 540. So now I have all the numbers I need. Plug that in to find our average rate of change. That is going to be at 9 seconds, it's 540, minus at 4 seconds, it's 160. We divide that by the change in x, which is the time of 9 minus 4. So this change happens in 5 seconds, and that change is 380. Now, they didn't give us units, so again, you don't have to concern yourself with, other than the fact we're dealing with seconds. So 380 divided by 5, an easy way to divide by 5 is to divide by 10. So 380 divided by 10 is 338. But because I divided by 5 and not 10, I just doubled the results. So 38 times 2, 76. So that's a math trick for dividing by 10 or by 5. You divide by 10 first and double the result. And especially with 380, that's easy. Just take the 0 right out.